Everyone, welcome to Laksha's Learning Launch. Today we're going to talk about a force that keeps us close to the ground, safe. Any guesses? Today we're going to talk about gravitation, but not as a force that acts on us by our earth, but something that has applications all throughout our universe. And how? By talking about the universal law of gravitation. This discussion will lead us to a new formula, and the statement will be clear enough to explain the formula itself. However, I'm going to brief you through the formula, and we're going to do one or two simple numericals on this so that you know how to solve it. But do stay tuned for Universal Law of Gravitation Part 2, because there we're going to talk about the derivation of this formula and the acceleration of gravity. Acceleration caused due to gravity. So this is a slightly different part in this chapter, which we're going to talk in Part 2. So stay tuned, do not miss it. And that includes slightly complicated numericals, and we'll also learn some tricks how to tackle them. So let's get started with today's video, which is going to be on our universal law of gravitation, stating it and the first simple formula, whose derivation will be in the part 2. First, I'll state the formula. I'll explain what each letter denotes. And then I'm going to state the law. This law will explain this formula in simple words. And then I will further explain it. Okay? So the formula is F equal to G, capital G, M1 into M2 divided by D square. What do each of these letters denote? F is the force of gravity or force of attraction between two bodies or two objects. What are these bodies or objects? We'll talk about it when we discuss the statement or the law. Okay? Then G is the universal constant of gravitation. Universal constant of gravitation, it's the same all around the universe. In our Milky Way, in our galaxy, it's the same number. It is done with a few calculations, which I will explain later. So this always turns out to be the same after calculations between different bodies, not only the same body, different celestial bodies, it is the same. And then M1 and M2. M denotes mass, which means M1 is mass of object 1, M2 is mass of object 2. D square, distance square, distance between both the bodies square. Now I will state the law. It is better to state or write about a law in its exact words, and then you can explain it in your own words. In any subject, that is what's preferable. Even what the examiner would want to see from you in your paper. So the universal law of gravitation states that the force of attraction between any two objects is directly proportional to the product of their masses, but inversely proportional to the square of their distance. I will repeat it one more time. Try to make sense of it. It will explain this formula really well. The force of attraction between any two objects is directly proportional to the product of their masses and inversely proportional to the distance between them. Square of the distance between them. Okay? We'll break up the law and the formula now. The force of attraction between any two objects. Force, so F equal to, right? So this is equal to, now objects as in any two celestial bodies. We're talking about our universe. So any planet, any star, or anything that's around us in this universe, they are considered as celestial bodies. But in the law, we state it as objects. Okay? So now, these objects, the force of attraction or the force of gravity, each of them has their own force of gravity. So the force of attraction between these two bodies is directly proportional to M1 into M2, or the product of their masses, because it's F equal to G, which is the constant. So we're going to keep that aside for now. M1 into M2, the product of the masses. It's directly proportional. Why? Because the masses or the product of the masses are in the numerator. It is inversely proportional to D square. Over here it is proportional. That's why we have the equal to sign. But why is it proportional? Because it's F proportional to 1 by D square. And F is inversely proportional to D square. So if you have to make it proportional, you have to reciprocate it, 1 by d square. That's proportional, and that's how the formula is found. Okay? And now we're gonna go to a simple numerical on how to apply this formula and solve it. But before that, I'm gonna talk about the universal constant of gravitation. So this universal constant of gravitation doesn't have a certain definition to it, but yes, it is basically when you calculate the distance and the forces or the gravities of these two objects after certain complex calculations done by scientists over years. It has been calculated that Jupiter mass, you can take these two celestial bodies, Jupiter and Mars, you calculate it, you'll get the same 6.67 into 10 raised to negative 11. It's the same. Mars and Earth, or Mars and Jupiter, Earth and Jupiter. It's the same. No matter what celestial body you take in the universe, it will be the same value. That's why it's the universal constant of gravitation. By the way, I forgot to talk to you about the unit. The unit is slightly complicated, and I'm also going to talk about its derivation. How did we get the unit? The unit of this formula, it's the unit for both the universal constant of gravitation and F equal to G into m1 into m2 by d square. It's the same unit. It is Newton meter square, which is Newton into meter square, divided by kg square. Why? How is it derived? I'm going to show it to you as a part of the numerical. When I solve the numerical, I'll show you the derivation as well.